Well, a warm welcome indeed to anyone joining. Thank you for being here. Get yourself ready with a notebook, a pencil, or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have a problem covering exponential growth. We're going to take a pretty easy look at exponentials. So this is intended for an Algebra 2 or pre-calculus level student, or calculus if you need to brush up on your exponentials. We're going to take a look at an exponential equation with some missing values. In this case, we have a new species of plant that's growing in an exponential way. What makes this exponential, just a reminder, is that the variable is in the exponents. That's why it's called exponential. And we have these missing constant values. There's some numbers, we don't know what they are. We're going to use that information along with this given information, some details about the height of this plant over the course of some days. And I'll give you a few minutes to read the question. You can pause the video, read the question, and see if you can figure this out on your own. Maybe about 7 or 8 minutes should be fine. We need to find the value of those two missing parameters, a and k, and then we also want to find, if we assume the plant began growing at 3 a.m. at day 0, approximately what time would the plant reach 150 centimeters tall? So we're going to have to use a logarithm in order to solve that at the end. It's going to give us a chance to revisit how to use logarithms to solve exponential equations. And when you're ready, you can unpause the video and see how we did it here. Let's get started. So we're going to use this given information, which says that p of 3 equals to 24, which means that 24 equals a times 2 to the 3k power. Okay. And we're also going to use the fact that P7 equals 96. That's centimeters. So that means that 96 equals a times the quantity, I should probably put this in parentheses, times 2 to the 7k. All right. How do we solve a system of equations with exponentials? It's different from solving a system of equations that are linear with two variables. We're going to want to divide. So let's take the 96 and divide by the 24, which means we're going to be dividing the bottom equation, which is a times 2 to the 7k, dividing this by a times the quantity 2 to the 3k. Okay, so we're dividing two expressions. We can cancel the a's nicely. That's convenient for us. And on the left side, we also get 4. Now, since we're dividing two exponentials with the same base, we just subtract their exponents, which means 7k minus 3k is the new exponent. That is 2 to the 4k. But we can take advantage of this property of exponents, which says if you're multiplying the exponents, it's the same thing as doing one before the other. So that means 4 equals 16 to the k. Very interesting. Well, what power is that for 16? If it's not clear, let's change the bases to make them match. This is 4 to the 2k, which means that the power of 1 on the left side is equal to the power of 2k on the right side, and so k equals 1/2. That's a pretty nice value. Let's use it to find a. We can go all the way back here to using our initial information. Yes, right here, 24 equals a, which we still don't know, times 2 to the 3k. Well, that's going to be 3 times 1/2. All right. What is 2 to the 3/2? Well, we don't really know, do we? 2 to the 3/2 is technically 2 to the 1 times 2 to the 1/2. If you think about it, you can add exponents when you multiply these. So that's 2 root 2. So we get that 24 equals 2 root 2 times a. Let's divide both sides by 2 root 2. I commend you if you can follow all this craziness, because I'm not going in a linear direction with this calculations. So 24 over 2 root 2, That's the same as 12 over root 2, which is the same as 12 root 2 over 2, which is the same as 6 root 2. Goodness, that is the value of A. So we've found A and K. We can represent the equation, therefore. The height of the plant after t days is going to be 6 root 2 times 2 to the half t, to the 1/2 t. Okay, this is our modeled equation, and we can use that in order to solve this question for part B. We can use the fact that it will be 150 centimeters tall at some point, and this must be equal to the height equation. To the 1/2 t. Now, in order to solve this equation, it is exponential because the variable is in the exponent, right? The missing or mystery value is in the exponent. We're going to divide both sides by 6 root 2. There we go. There we go. 150 divided by 6 is 25. 25 over root 2. We could, if you'd like, you can call it 25 root 2 over 2. It doesn't really matter. This is going to be equals to 2 to the 1/2 t. Now, this is where things get tricky. If you don't remember, we need to use a logarithm to solve this because there are not any whole powers here. So we need to take a log of both sides. And you can use any log you like. I'm choosing to use ln. That's just natural. You see what I did there? ln 25 root 2 over 2 equals ln of this entire expression, 2 to the 1/2 t. Why would I do that? This makes it more complicated, but remember the property of logarithms, that any exponents on this base can move to the front. So now we're able to solve for t. We're able to see it because it's in front here. It's not locked away inside of the exponent, and it's not locked away inside of the logarithm anymore. Even though this is extremely messy, if we were trying to solve this by hand, we can use a calculator. Let's do this carefully. We're going to divide both sides by ln of 2. You could do this all in one step, but I'm going to do it in 2 steps. Just take it easy on you guys. And you end up with ln of 25 root 2 over 2 divided by ln of 2, and this equals 1/2 t. So the final step here is to multiply both sides by 2, multiply this side by 2. To cancel out the 1/2 on the right side, and on the left side we have this very interesting expression, 2 times ln of 25 square root 2 over 2, and that's divided by ln of 2, and that equals t. Now, I don't expect you to know that off the top of your head. Nobody does. So just use a calculator to solve what that is carefully. Times square root of 2. Let's put it in an ln. Let's divide it by ln of 2. Multiply it by 2. So I'm getting that t is approximately 8.2877 days after. But this does not fully answer the question. The question asks approximately what time. So we need to understand that this happens 8 days later, but 8.0 days, like 8.000 days, this would correspond to 3 a.m. So the rest of this is just a little conversion exercise, just to keep you sharp. That means we've gone an extra 0.28771 days past 3 a.m. Now, how many hours is that? Well, we have to multiply by 24 to figure out how many hours that is. And that's 6.905 hours. So that's 6 hours later, so that's 9 a.m. plus 0.905 hours later. How many minutes is that? Yes, we're getting specific. We're trying to find the time. So we multiply by 60, and this is 54.3. I think it's safe to say 54 minutes. So the time when it would reach that growth is at 9:54 a.m. on day 8. And that is exactly the time that this plant would finally grow to 150 centimeters tall. Let's be realistic and mention that plants do not necessarily grow at the exact same rate every single moment. There may be times of the day or night when they're growing faster, but this is assuming the plant models this growth exactly. So it's an assumption that we make because over a long period of time, it's a very valid trend. If you wanted to get more specific, you would need more measurements. I think that's enough blab out of me. We'll see you guys next time.